So let's look at some quadratics, and what we're going to be doing is we're going to be factorizing quadratics. Why do we factorize? We factorize so that we can reveal the roots or the zeros, that is the values of x that bring the quadratic expression function to zero. So we have a quadratic that's in the standard form, ax squared plus bx plus c equals 0. We're going to factorize that and find the solutions that show us where that is equal to 0. Let's just show you what I mean here on a graph. Let's have a look at, pick out a quadratic here. Let's take this one. So here we have, if I can zoom in there, x squared minus 5x plus 6. Where does that equal to 0? Well, let's just double check this. I've got the trace function here. Let's double check that. It doesn't look real good. Let's go to x-axis. There, 2. At x is 2, the function is 0, and that looks like 3. X is 3, the function is 0. So that's what we're trying to achieve by factorizing. We're trying to find the solution that that graph just showed us. Now, of course, not all quadratics will be factorized. Let's have a look at one that isn't, for example. Let's see this one here. This one here, just take that out. X squared plus 5x minus 4. Here, if we look at the solutions here, x squared plus 5x minus 4, let's try and find what the values are on the x-axis. You can see it's negative 5.70. That is what we call an irrational number, and we're not going to derive that number by factorizing. Of course, there are quadratics that just simply won't cross the x-axis. Here we have one here, x squared minus 3x plus 10. If I zoom out here, we might get a picture of that, a better picture. There it is there, and that's sitting way above the x-axis, so it's not going to cross the x-axis at all. There's no solutions. And similarly, we could have a quadratic in this sort of shape here that would have a negative a coefficient and would be below the x-axis. There'd be no zeros, no solution there. Now, to go about factorizing, let's consider some points here, because we don't want to race in and start doing some complex method before we've checked to see if there's some sort of simpler approach. Make sure you've organised your quadratic so it's in descending order, ax squared plus bx plus c. Now ask yourself these things. Does the quadratic have a constant term? Here's an example where there's no constant term. X squared minus 5x equals 0. Now I can factorise that quite easily. The common factor here is x. So we take out the x. X into x squared is x. X into negative 5x is negative 5. So the solutions for that, where does it cross the x-axis? Zeros are at x equals 0 and x equals 5. When x is 5, that expression in the brackets resolves to 0, so the function is equal to 0 there. Let's have a look at on the graph. I've already prepared it. X squared minus 5x there, x squared minus 5x. Here you can see the values there. Of course, x is 0, the function is 0. X is 5, the function is 5. X, function of x. Okay, let's go back to our points. Does the quadratic have no middle term, the bx? Let's have a look at an example of that. X squared minus 9. no middle term. I can factorize it. It's you'll recognise that, no doubt, as the difference of squares. The difference of squares is always going to be in this form. Take the square root of this, the first term, and the square root of this one is going to be, it's a difference of squares, did I say that? So the square root of 9, it's 3 times 3, so we're going to have x minus 3 times x plus 3 will equal to 0. So the zeros are x equals 3, x equals negative 3. Now, without factorizing, you can probably see another way of doing this. If you just work on the basis of solving the equation, x squared is equal to 9. All right, so we've just added 9 to both sides. That brings the 9 over. Square root each side. X is equal to the square root of 9. Now, just be careful. Square root of 9 is not just 3. It's plus or minus 3. So that's where we get the plus or minus 3. Let's go back, check it on the graph. I'll just take that first one off. Here we have equation 2, x squared minus 9. You can see the solutions here. Just select the function here. We want here. There it is. X is negative 3. The function is 0. X is positive 3. The function is 0. So that's x squared minus 9. You will get a similar result if you consider another difference of squares. Let's stay with a similar sort of number here. 4x squared minus 9 is equal to 0. Again, using the difference of squares, square root of this term here would be 2x. Square root of this one is 3. So we're going to have 2x minus 3, 2x plus 3 will be our answer there. So the roots or zeros. And here, remember I said it's not just integers, these solutions, they're also fractions. So it will be 3 over 2, right? Because we want to know when does that expression equal to 0. That's equal to 0. If you want to solve this equation, 2x minus 3 equals 0. Sorry, I'm not real good with my pen here. So therefore, 2x is equal to 3. So x is equal to 3 over 2, or a half. And by the same approach, you get x is equal to negative 3 over 2. Let's have a look, check the graph. I don't know if I've got it here. I'll just quickly put that in. Function x equals 4x squared minus 9. All right, let's do that. Let me just take out the other one. The function here. When x is 1.5, then the function is 0. That's what our solution said. When x is 3 over 2 and negative 3 over 2. Okay, let's go back to our conditions again. So we've considered a case where there's no constant term. We factorized, got a solution. We've considered a case where there's no middle term and we found a difference of squares. But equally, you could just solve the equation to get the roots there. So factorizing is a bit redundant in a way there. Third one, is the coefficient coefficient A simply a number 1? If so, the factorizing, if it can be factorizing, it's quite simple. Let's have a look at some examples here. X squared minus 5x plus 6. Now what we're trying to do is we're trying to find factors of 6 that add up to that negative 5. All right, in this case, obviously I've set it up so it's fairly easy to see. 3 times 2 is 6. It's got to add up to negative 5. If we have negative 3 times negative 2 gives us negative 6. When we add those two together, we get negative 5. So everything checks out. So our factors are x minus 3 and x minus 2. That will equal 0. 0 is at x equals 3 and x equals 2. So let's just check that on the graph. Oh, uncheck that one there. X squared minus, that was it, x squared minus 5x plus 6. That graph there. Let's find the solutions there. When x equals 2, the function is 0. When x equals 3, the function is 0. So let's go back to, here we are here, x equals 3, x equals 2. Okay, one more example here, x squared plus 2x minus 8. I'll just do the factorizing over here. It should be pretty straightforward, but just in case I goof off, I'll just give myself some room. We've got 4 times 2 will be 8. We want them to add together to get plus 2. So what I'm going to do is put a negative 2 there. So when they add together, yes, we get the 2. Do 4 times negative 2 equal negative 8? Yes. So our factors are 4 and negative 2. When I say factors, I suppose I really should be saying x plus 4 and x minus 2. That's equal to 0. So therefore your zeros at x equals negative 4 and x equals 2. Let's see if I've got that in the graph. There it is there, that one. Trying to find the solutions there. There's x equals negative 4 and there's x equals 2. X equals 4 and x equals negative 4, x equals 2. There we go. Okay, so going back to those conditions there, we've gone through, we've looked at a few of these examples here where you didn't have a constant term. We've looked at the case where you don't have a middle term, which is pretty straightforward, and you really don't need to factorize to get your roots. We've looked at cases where you've got a coefficient where a is equal to 1. Now, what if you've got a coefficient of a that isn't 1? You've got all three terms, an a coefficient, a b coefficient, and a constant. First thing, just check if you can't factorize that a coefficient down to 1. So you're factorizing a, b, and c. Let's just have a look at, I've got an example here. Looks like I don't, so let's, all right. I just entered a quadratic there that I think I can factorize, where I think I can factorize out the coefficient a here back to a 1. If you look across these three, the coefficient of 3, coefficient of negative 15, and the constant of 12, common factor will be 3. So now we've done it, we're doing it, and we're actually factorizing in two tiers here. So we simply now factorize this quadratic within the brackets here. Well, we're looking at factors of 4. It has to add up to negative 5. So we're going to need a 4 times a 1. Now if we have negative 4 times negative 1, that gives us the 4. We add them together and we get a negative 5. So factors there. Let's put the 3 in, don't forget that. X minus 4, X minus 1. Oh, there's no particular order in these factors, by the way. You don't have to put negative 1 before the negative 4 or whatever. Okay, so zeros are at x equals 4 and x equals 1. All right, so let's just check that on the graph. 3x, I'll just take out these other 2 here. 3x, there it is there. 3x minus 15x plus 12. We want to know what those solutions are for the function is equal to 0. And there we have x is equal to 1 and x is equal to 4. Is that what we had? X is equal to 1 and x is equal to 4. Okay, so let's go back to our points here. Now, where's that slide? Let's consider now the case where coefficient isn't 1. We can't factorize that coefficient down to 1. And we're going to consider we actually have 2 common methods available to us now. They're both fairly complex. One you might find a preference for rather than the other. This is apart from what we call the completing the square method. The completing the square method isn't covered today. Let's have a look at an example here. 3x squared plus 4x minus 7. We've got an a coefficient that's not 1. So there's 2 methods. If it does factorize, there's 2 methods, and both methods rely on this first approach. First of all, you need to find factors of AC that add up to B. So let's make sure we know what AC is. AC in this case is 3 times negative 7, which is negative 21. They've got to add up to B. B is equal to 4. Now, it's probably not that hard for you to get this right away in this case. All right, we want 3 and 7. It's got to be a negative to get the negative 21. And when they add up, when they add together, we want them to get to 4. So what's the answer going to be? It's going to be a negative 3 times the 7, because that will give us the negative 21. And when they add together, they'll get the 4. So, not such a hard one there. Now, where do we go from here? Now, when the a coefficient is 1, we just put in our factors x minus 3 brackets x plus 7. Well, it's not that straightforward this time. Now, we've got a choice of methods. All right, this is one way. Well, we're going to take our negative 3 here, and we're going to divide by a. So we're going to divide by the a. Let's put a line under here. Divide by the a. So what's the a? The a is 3. Take the other factor 7 and divide by the a. Simplify. So here, divide by the a, simplify, if you can. Right, so what's negative 3 divided by 3? Negative 1. What's 7 over 3? We can't simplify it. Just leave it as 3. Don't write it as a mixed number. It just gets complicated. So what's our answer now? Well, this negative 1, it simply stays there as negative 1, like so. This one here, because it's got a denominator other than 1, that 3 becomes 3x and then the 7 goes in there like that. All right, so if this was negative 1 over 1, it's 1 times x and the negative 1 there. Here, there's 3 times x and plus the 7, like that. Now, you ought to check that. I'm not sure if I can change the color of my pen on this. Okay, so let's just check this now. We can just use, I call it smiley face. People might call it a double rainbow. It's foiled by another name. All right, so let's do it. 7x is here. We got negative 1 times 3x is negative 3x. You can see they're going to add up pretty easily. So x times 3x is 3x squared. Negative 1 times 7 is negative 7. Let's bring those down here. 3x squared. I'm looking down vertically here. Negative 3x and 7x will be 4x. And there's your minus 7. So there you go. Done. All right. Now that's, I'm not sure exactly what you call it, but after you've done the first step, when you found these factors here, that's your first step. Then your next step is to go through this process of you dividing by the a to get these. You simplify it, so that's like 2a and 2b, and then finally, this is your third step here, where you actually bring those results over to this. Okay, now I'm going to show you the decomposition method now. I'll just see if I can change the color of this pen. I don't know what color I was in. All right, I'll go dark blue. Okay, so scribbling all over this. Okay, so let's go to decomposition method. Now, we've got this far here. We've got to step 1, and we've got these factors here. Okay, that negative 3 and that 7, watch what happens. We're going to rewrite the quadratic like this. 3x squared. Now I'm going to break the 4x, that middle term, up into 2. Minus 3x plus 7x. That's what happened to those factors up here. The constant stays as it is. Minus 7 equals 0. Now, I've got to do now 2 processes of factorizing, 2 steps in factorizing from here. Now, by the way, this could be in any order. I could have plus 7x minus 3x. It would still factorize. I get the similar result. So let's have a look. What can I do here? I'm going to factorize the first 2 terms and the last 2 terms separately. Let's take out 3x. That goes into both. Over here, let's take out a 7. Now there is a plus in there. Just check that we've still got the same expression there on the left-hand side. 3x squared minus 3x plus 7x minus 7. It's the same expression. It's the same part on the left-hand side. It's just been factorized. Now my second tranche, or my second phase in factorizing. Here we go. Look at this. X minus 1 is common. We've got 2 terms here now, not 4. We've got 2 because they're all multiplied, and we can take out this middle part, this part in brackets, x minus 1. So we're left with a 3x there, and a plus 7 there, and that's equal to 0. Now, does this look familiar? Up here we've got x minus 1 times 3x plus 7. X minus 1 times 3x plus 7. Same result. We'll check it on the graph. Which one is it? That one there. 3x squared plus 4x minus 7. Let's check what we've got here as a result. Here, negative 2 and a third. Well, we didn't actually write down our zeros, so we should do that now. Zeros. X equals 1. Right? When x is 1, that term there, that factor will become 0. And x equals negative 7 over 3. Where did I get that from? I'm solving for when that part 3x plus 7 is equal to 0. You do that equation and solve it and you'll get negative 7 over 3. What's negative 7 over 3? By another name, it's negative 2 and a third. All right, negative 2.3 recurring. There it is there. And on the other side, x is equal to 1. There are our solutions there. Now I'm just going to show you here that it doesn't matter what order I put those. Let's do plus 7x minus 3x minus 7 equals to 0. If I'm careful, just as careful, I'll get the same result. Here in this case, x is the common factor. Now, just be careful here. There's no actual common factor here except for negative 1. I'm taking out a negative 1 because I'll put a negative 1 there so it's clear. Because that will mean negative 1 times 3x gives us that negative 3x. Negative 1 times 7 will give us that negative 7. All right, it should be looking familiar now. What's my common factors now? The 3x plus 7. Take that out of there, I've got an x. Take it out of there, I've got the negative 1. There you have it. Same thing. Okay, we'll do one more of those. And then you can do some practice and work out which method you want to do, or if you want to practice with both, that's fine. So I'll just pause this and all right, I've set up another quadratic. I wanted to do something easier than this, but I'd already put it on the graph. So anyway, we'll work through it. Now remember, the first step is your AC and B. So you want factors of AC. Now AC is equal to 9 times 20 is 180. Okay, we've got to get them to add up to B. B is equal to minus 27. All right, so what we're looking for, because 9 times 20, 180, that's a positive. We want two negative numbers to multiply to get that, and they'll add up to negative 27. Let's start with 3. They will add up to negative 27. Hooray, there we go. That's the one. There's the factors there. So that's our factors, negative 12 and negative 15. Okay, so that might have been the hardest part in this case. So let's go through the next step now. So let's do, we're going to reverse. Right, so now we're going to divide by the A here. The AC we multiply by the A here, we're going to divide. So there's our factors. Negative 12 divided by 9, negative 15 divided by 9. Simplify. So this is like step 2A and step 2B. So negative, let's go 3 into negative 12, 3 into 9. Same over here, 3, 5, 3. All right, can we simplify any more? No, leave them in their improper fraction form. So how do we write this? Well, up here, remember now this part in the denominator, it goes times the x. So we've got 3x minus 4 times, again, we've got a 3 in that denominator, 3x minus 5 equals 0. Now we're going to look at a graph in a minute, just to see what this, so there's the zeros. Well, let's work out the zeros in a minute. Why don't we just do a smiley face check or FOIL method here to check. I'll change the pen color to red, and we'll just do some expansion here just to check what we've got. Remember, we're just multiplying along the lines. So no particular order, negative 12x, 3 times 5, so that's negative 15x, there's our negative 27. 3 times 3x times 3x is 9x squared. Minus 4 times minus 5 is 20. Right, let's bring those down. We've got 9x squared minus 27x plus 20. There we go. That's what we're looking for. Now, just going back to that factorized form, the zeros, they're at, so remember we're trying to solve these equations. I won't write them out, but you're quite able to do that. I just end up making a mess with this pen here. So the zeros are going to be at x equals 4 over 3, which in other words is 1 1/3, and x equals 5 over 3. Now, what we might do is have a look at the graph. There's your quadratic there, 9x squared minus 27x plus 0. Here it is here, 9x squared minus 27x plus 20. Now we're trying to find where it's equal to 0. So there's your solutions there. 1 2/3, which is 1 2/3 is 5/3, and 1 1/3, which is 4/3. Let's see what our answer was here. 1 2/3, 5 over 3, and 1 1/3. So there you have it. I'll just show you the decomposition. I forgot all about it. We're going to do the decomposition method. So this is your alternative method. So we're just rewriting that quadratic, 9x squared. What do we do with that middle term? We break it up. It was negative 27x. The factors we have, negative 12 and negative 15. It doesn't matter what order we put them in. Okay, so that the expression here on the left is still the same. 9x squared minus 27x plus 20. Okay, we factorise them in pairs. This pair, then this pair. And zeros, let's just compare with what we had up here. 3x minus 4 times 3x minus 5. So what have I done here? There should be a 3x in here. All right, you probably picked that up as I was going. 3x, that should be a 3x. I think that's the advantage of doing it in two alternative methods. You pick up an error. If you've done it in one method, you'll pick it up in the other. Okay, so there we have it. This should be a 3x here. Let's just, well, I can rub this out. So let's make that a 3 there. Okay, so 3x minus 4 times 3x minus 5. Zeros just as above. All right, we've already done it. So let's just check that we've done everything on that list. Okay, I think we've progressed through that list. There's always the possibility the quadratic doesn't factorize. Obviously, we're trying to set you questions that will factorize. That's the whole purpose of it. Wraps it up, I'd say, for this session. Go to and practice.